Hello students, the question is the work done to raise a mass m from the surface of the earth to a height h which is equal to the radius of the earth is. The options are given. Okay. For the solution we have to first understand what is the meaning of gravitational potential energy. Gravitational potential energy, in short GPE. Now gravitational potential energy is always defined for a system of masses, like this is the simplest system you can think of. Two point masses m1 and m2 are situated at a distance r from each other. This is a system of two masses. Now what will be the GPE of this system? Let me first define what is GPE. Gravitational potential energy of a system of particles is nothing but the total work done in assembling the system by bringing each point mass one by one. This is very important, one by one. Total work done in bringing each point mass one by one from infinity to their respective positions. That's the meaning of GPE. Now coming to this system, suppose m1 and m2 are situated at points A and B which are at a distance r. Now first there are no masses. Now we bring m1 from infinity to point A. What will be the work done? See, if there is no mass there is no gravitational field. Therefore always remember the work done to bring the first mass from infinity to a particular point is 0. Therefore work done to bring m1 from infinity to A is always 0 because there is no gravitational field. Now when m1 is at A, now this mass will create a gravitational field around itself. Therefore I can say that at B there will be a gravitational potential for this mass m1. What will be that potential? Now potential at B due to m1, we know the formula for potential is minus g m1 by distance. That's the formula, minus gm by r. Here the mass is m1, so potential at B due to m1 is minus gm1 by r. Remember B is m2 is not still at B. Now we are bringing m2 from infinity to point B. That is the position of m2. What will be the work done? Now work done to bring m2 from infinity to B, that work done is nothing but the mass that we are bringing into potential of the point B. What is the potential of point B? It is minus g m1 divided by r. Therefore minus g m1 m2 divided by r. Now from the definition of gravitational potential energy we can say GPE of this system is nothing but, I will denote it by U, is nothing but the total work done in assembling the system by bringing first m1 then m2. Therefore the total work done is nothing but, since the first work done is 0, so GPE of the system will be minus g m1 m2 divided by r. Remember this formula will be useful to solve this question. Now coming to the question, Here there is a mass small m which is situated on the surface of the earth. Now the first case, this is the earth. Suppose mass of the earth is capital M, radius is capital R, and the body of mass small m is situated on the surface of the earth. Therefore the initial GP of this system is nothing but, here the system consists of two masses. One is the body of mass m, another is the earth, right? And the distance between them is what? Capital R, not 0. Remember, not 0, because the distance in gravitation is always calculated from center to center. Therefore initial GP of the system, suppose U1 is what? Minus G capital M small m divided by distance, which is capital R. I hope you understand. Now coming to the second line, now this mass is raised to a height h which is equal to the radius of the earth. Now for the second case, proceed to the next slide. This is the earth, radius r. Now the mass m is situated at a height h above the surface of the earth. Now the distance between them is what? Obviously r plus h. Therefore I can say final GP U2 is minus capital G capital M small m divided by r plus h. I hope you understand. So the initial potential energy is minus G capital M small m divided by r, and the final potential energy is this. And according to the question, this h is nothing but the radius of the earth. So putting that value, Gmm divided by twice r. Now this is the final GP of the system. Therefore the change in GP, change in gravitational potential energy of the system, which is what? Simple. See, this is the initial potential energy, this is the final potential energy, and you can see that initial potential energy is greater. Concentrate on the negative sign here. Initial potential energy will be I believe the final potential energy will be greater. Why? Because the value of this is less, but since it has a negative sign, so U2 is greater. So change in GP is nothing but U2 minus U1. Putting the values, so we will get G capital M small m by twice r. Now what is Gm? We know from the definition of acceleration due to gravity at the surface of the earth, we can write small g equals to capital G capital M divided by r square. So I can replace Gm by gr square. Now putting this, so the answer is half mg r. That is the change in gravitational potential energy, which is nothing but the work done. Here in the question they ask you to find the work done to raise the mass. So the work done is same as the change in potential energy. So option 1 is correct. Thank you for watching this video. Please subscribe my channel Phi Solver.